just going to wing it and try and explain furnaces for those who want to learn. This is all kind of off the top of my head. For starters, manufacturers of furnaces call this a heat exchanger. In thermodynamics, heat exchangers can mean many things. In HVAC and refrigeration, coils, as you see here, are also heat exchangers. Air passes through and heat is exchanged to the gas or fluid flowing through the inside. There are lots of types of coils. They're made very similar to the radiator in your car. Here you see a blower pulling air and then pushing it through a coil. With outdoor condensers and outdoor heat pumps that are air to air, you'll have a fan pulling air through the coil. So whether you're pulling or pushing, doesn't really matter. You're putting air across a coil. A heat exchange is taking place between the fluid or gas going through the tubing on the inside of the coil and the air passing across the outside of the coil through what are called cooling fins. Usually you will see a plate type fin, as you see on the left. Sometimes you'll see a spine fin, which was originally a General Electric design. Not all heat exchange is air to air. Here you see ground source, where heat is either coming from the ground or going into the ground from the fluid passing through the piping. Or you might have water source, where it's transferring with tubes wrapped around each other. You'll see this type of thing also in ground source, where the fluid is coming out of the ground and then wrapping around, say, the evaporator or condenser coil to either take heat out or put heat in to the refrigerant from the glycol coming out of the ground. But in this series of videos, we're explaining how furnaces work. A furnace heat exchanger is typically made of stainless steel, and some older furnaces were made of iron. Most of the stuff you guys are gonna see these days is gonna be the stainless steel type. Here you have a tube type. Here's an example of a type of clamshell, which essentially is accomplishing the same thing that the tube was. And even some drum type configurations. These are just a few examples. Furnaces will have burners, jets, but for the sake of to drastically oversimplify how gas heating works to the point where anybody could understand it, we're going to go to a fire pit. Hear me out. Put some wood in there. We've got flames and we've got smoke from the fire. Now, for the sake of explaining this, let's say we brought a gigantic metal garbage can and we're going to turn it upside down and put it right over the top of this fire pit. So essentially now we've smothered the fire. As you know, fire needs air to burn, right? Okay, so we could cut in a little flue here and give that somewhere to go so that the smoke from the fire can make its way out of our flue. And theoretically, if you were to put some vents in somewhere, what you'd have here would be very much like a wood stove. But let's tunnel in a little fresh air. Make sense? Now we have fresh air entering, feeding air to that fire, and allowing it to vent through the inside of the can effectively, and the smoke going up and away. If you were standing here, you're going to enjoy that heat radiating off the outside of this can. So that's basically acting like a furnace heat exchanger. Now, instead of wood, let's add a fuel source, such as natural gas, propane, and we're going to pipe in. And now, instead of burning wood, this is a burner. What you have here is essentially something with just radiant heat. Either way, the exhaust from the flames is flowing through it upward and venting by gravity. Okay, so the next thing you could show as an example would be, say you set a fan out here on the campground, right? You just pop a fan here, and we're going to move some air across the outside of this thing. And now you're blowing air across it. Now you have forced air heat. Very simple example to show that. Go one step further. Come here. And let's put in a little blower. Most of you know that's going to be an inducer. And the inducer is going to assist pulling the exhaust through the heat exchanger more efficiently, helping the fuel burn more efficiently. We can go one step further and get rid of this flue. Come out of where our flue was into another heat exchanger, a secondary heat exchanger, which often looks just like a coil. And you're going to have tubing flowing. Picture this as a coil. Put the inducer here on the other side of that. And there's your flue now there. So we've taken the hot exhaust that used to go up out of this flue, and we're piping it through yet another heat exchanger. We still have our fan putting air across this whole thing now. Cold air in, across the entire thing to the other side. Warm air on the other side. So we're basically harnessing this hot exhaust and keeping it in front of the airstream into the conditioned air that we want to warm up. And as this cold air takes the heat out of the inside of this heat exchanger from this exhaust, the exhaust condenses from vapor to liquid. And that's why this is called a condensing furnace. A condensing furnace. You'll have drains where the water can drain out. And this becomes PVC pipe instead of metal flue, because we've gotten enough of the heat out of here to where less than 8% of the heat is being lost out of the flue pipe. And that's why they call them 90 plus furnaces. But the correct name for this type of furnace is a condensing furnace. The efficiency ratings on these vary, typically from 90 up to nowadays 98%. Some of the earlier ones were about 92% on average. But this is a basic explanation of how all gas heating works, from a very basic radiant type heat, like a wall furnace, a floor furnace, to an induced draft forced air furnace, to a condensing furnace. Something else that this can help illustrate is why a crack or hole in the heat exchanger matters. Is obviously if you get a breach anywhere in either of these heat exchangers, then the flue gas or smoke from the fire can escape out and end up out here where it doesn't belong. And anytime you burn any type of fuel, the smoke from your fire, the exhaust, contains carbon monoxide. Hope that helps.